Hello, it's me again. So I've got a 3-layer rhombic dodecahedron. Fairly simple puzzle to solve. The one thing that I'm going to go over is how to get out of a parity situation that happens toward the end. Well, get it scrambled first. Abracadabra. And it's scrambled. So matched up, red. But let's pair up our centers here first. So I don't see a green here, so that's obviously not going to be paired up like that. So we'll find the green here. So green, green, yellow. Yep. This pairs up here. Blue, blue, red, red. So that's a good start, but doesn't necessarily mean that that's how things are going to end up. So I'm just going to build this side here. Blue. Okay, so here's our cross, and now it's just simply filling in these edges. Alright, so here's our first side. We've got that fine. So nothing new under the sun. We're working on our last side here. Here's white. We want to move this white one in here. So this is our algorithm here. I think it's, yeah, I've heard people call it the PLO. I'm not much into vernacular. So we have to move the brown one. Which one do we move? Well, I don't know. So I'm going to try one and hope for the best. So that's our second layer solved. Now our top layer, and this is where we might start running into parity issues. Let's line up our centers where they're supposed to be. So red, blue, yellow, green. And you can see these centers are fairly messed up. So we're going to want to be moving these around and flipping these around. We could solve these corner pieces just so that they're not an issue now, or we could do that later, and we'll do it later. So we want this yellow to be here, we want this blue to be here, we want this red to be here. So basically we want to flip these guys, and we want to flip these guys. What I've been taking to doing in these supercube type cubes is similar algorithms of middle swapping that you'll find with cuboids, the 3x3x4s and whatnot. So one possible scenario that we have is you have one of these where they need to be, but the rest aren't. If that's the case, then you pretty much are where you need. But when you don't have that situation, you're going to probably run into issues with parity. So let's say I wanted to swap these two, and then I wanted to swap these two. One thing I can try to do is a middle swapping technique. That's where you do the 2R. Yeah, let me reorient myself here. 2R, if you remember. U, 2R, U, 2R, U, U, 2R, 2U, 2R, U, 2R, UI, 2R. And what that does is it does swap these two. It creates a parity situation here. These two are swapped, but also turns this around. So now I wanted to swap these two. So I'll move this into position here so that I can fix this parity situation here. So same thing, 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Alright, so predictably it fixed that parity situation there, and it flip-flopped that, and what that really means, move this into position, is we've got these solved, these here solved. This is actually where I wanted to be. These are all solved. So what I did is I just flipped two corners, and that got me out of that parity situation. Then it's just a matter of solving the corners here. And you do that the same way you do with 3x3. Someone's out of bed.
I know, did you get one?
Yeah. No, you see what happened to the cube there?
You broke it again?
It broke. It just, I super glued it again. And this is solved, despite someone being up way past his bedtime. Right, Noah?
Right.
Right. We're going to show what can happen in other parity situations. So here's another situation that you might see. I had to change venues as my wife is out watching The Amazing Race, and Noah is safely upstairs in bed. So the previous situation that I sort of flubbed my way through was one where none of them are in the right position. And that's actually okay, especially if it's like a flip-flop on one side and then a flip-flop on the other side. And if you just flip-flop them like that, the way that I showed, it'll be fine. But in this situation, you have a problem because only one set isn't flip-flop. So this is one scenario. If this happens, it's not going to work because if I do the flip-flopping, if I do the corner switch, these two will switch, this will wrap around, and this will be out of place. And you can keep going around and around and around, but you'll never quite get it into place. So what you have to do here to get out of this is you have to understand that this blue and this blue have a sort of a symmetry to it, and this green and this green. What happened is that somehow in the process of solving this, one blue is not where it's supposed should be on the opposite side. So all I'm going to do is I'm just going to start exchanging any one of these with each other. The green for the green, or the blue for the blue. And then that'll help reorient this. So let's see what happens when we do this. I'm just going to bring the white in here, which will bring the green out. Then I'm going to put the green back in here. So this is just the simple PLO. And what I've done is I've taken the green out, put it here, and put the white in here. So now I'm going to come across this side and just replace green for green. Alright, so now this is the other green that's now in this spot. This is over here. I'm going to take this white and put this green in here now. Okay, so after much doing, so that resolved these, which is good, and now we can reconfigure what we've got. We can take another look here. So what we have here now is a similar situation of these two flip-flopped, and now these two are flip-flopped. So this becomes the same situation that we had before. Okay, so this really shows the parity pretty well, now that we got all these centers here. So same kind of thing. Let's do the algorithm to flip. I want to flip these two, then flip these two. So it's going to be the middle flip, which will create parity here, then we'll turn that back around, and let's see what happens again. To R, U, to R, U, to R, to U, to R, to U, to R, U, to R. Wow. UI to R. Okay. So these two got flipped. You have a parity issue here. Now notice this top one got turned around also, but we don't worry about that. It's sort of turned about 180 degrees. So we're going to turn this back. And this final algorithm should flip-flop these back into place and then turn this back around. To R, U, to R, U, to R, to U, to R, to U, to R, U, to R, UI, to R. And it becomes solved. Here's actually that example of that final situation where you have just one that's where it needs to be, but this one isn't, and this one isn't. And that's okay too. Actually, this one is probably the easiest of them. Either none of them are, in which case just flip them around and see what happens. And either one is going to be, or two of them are going to be solved, or none of them are going to be solved, just they both need to flip. So if you get this situation, all you have to do is hold this here and do the algorithm that you learned on a 3x3 to just move these around. So that's where you go R, U, RI, U, R, U, U, RI. Once you do that, everything will then be in position at that point. No need to add any new algorithms other than what you've already learned. And that's it.